Great to be here at Tech Winter Horizon 2025. I'm Steph Delvoye, and I'm leading marketing strategy at Nokia and chairing the marketing steerco of the AI RAN Alliance, where Nokia plays a leading role. Last year, our event was about pioneering AI RAN with our partners. Today, it's about advancing connectivity for the AI supercycle. We recently announced our groundbreaking collaboration with Nvidia to accelerate innovation in AI RAN and AI-native networks. We are expanding our RAN portfolio with Nvidia's accelerated computing platform at the right time, supporting our customers as AI transforms their networks and business models. But AI is not just transforming our industry, it's transforming the world. Like our president and CEO Justin Hotard says, this is a technology revolution comparable to the internet supercycle. Mobile internet pushed the limits of connectivity, and AI is fundamentally pushing the horizons of what is possible with technology. With AI, I can even push my own horizons and step beyond the physical world. Whoa, it's the first time I meet my AI self. But how do we make this a reality for everyone? AI enables us to create amazing virtual immersive reality experiences and digital twins that are much more accurate than ever before. Beyond this, agentic AI and robotic AI are evolving rapidly. These use cases have a big impact on network traffic patterns, creating much higher pressure on the uplink and demanding more processing power. This is exactly where our industry co-innovation brings value. I'm so thrilled that we'll get to hear from our strategic partners, Nvidia, SoftBank, and Indosat Ooredoo Hutchinson, and from Nokia's new leaders. Chief Technology and AI Officer Pallavi Mahayan, who will be our first speaker today, and President Network Infrastructure David Hurd, who will end the event on a high note. But first, let's kick off with the mood video from GTC DC.
Yeah, look, I think for us, one of the principles I've had with my team since coming in has been do what we can do that no one else can do, and that is AirScale, what we do with any RAN software, the software that runs on it that we're going to be putting on the NVIDIA ARC platform. That, do what we can do well and partner with the best everywhere else. And this is a clear opportunity to partner with the best. So we do what we do best, we let NVIDIA do what they do best, and ultimately our customers win.
Nobody knows telecommunications better than Nokia. They've been at it for a long time. They're all over the world. And between our two partnerships, we now have wireless telecommunications, we have AI, and we have accelerated computing, all in this partnership. And so all of that capability is going to be brought to bear for the next generation of 6G. And I think that's the capabilities we bring together in this partnership is quite unique and formidable.
I'm very happy to join you today to discuss the transformative impact of AI. We stand at a pivotal moment as the AI supercycle is no longer just a prediction. It has already begun. We have moved beyond the initial awe and the creative explosion of generative AI. Now, we are entering an era where the AI supercycle will transform industries and society. It will spur many parallel innovations, some of which we cannot even imagine today. But let's start with the reality check. Now, scaling AI faces three hard constraints. First, productivity stagnation. Now, Europe's growth has slowed, and AI is critical to reversing this trend. Second is the energy limitations, as power availability and cost continue emerging as major barriers to AI deployment. And third, fragmented telecom markets where connectivity gaps and lack of scale in networks are creating bottlenecks. Now, these constraints create a real challenge for AI scaling. While networking is critical, power and compute limitations are equally pressing, especially in Europe. Now, today, while we acknowledge all three dimensions upfront, I want to focus primarily on networking because that's where Nokia plays a pivotal role. At Nokia, we provide critical technology for fueling the AI supercycle. Now, this is a unique opportunity for us and our customers to connect the world's intelligence. Connecting intelligence is all about providing the right infrastructure for AI systems to exchange and process data in real time. Now, to highlight the key enablers and challenges for AI adoption, Nokia conducted a survey of over 2,000 technology decision makers from the US and from Europe. And I want to share some of our key findings. First, most respondents are concerned that the lack of infrastructure could hinder the scaling of AI. Second, the US is leading in AI readiness. However, the ambition for enterprise AI adoption in the US is greater than today's progress in expanding connectivity and capacity. The third is that Europe risks falling behind without accelerating regulatory decisions and investments in infrastructure. Now, let me dial it down to a very concrete level. Today, we are seeing an increase in AI traffic generated by both large and small language models and simple AI agents. As AI becomes more ubiquitous, the connected landscape will completely change the demand that is placed on networks. Reliable, secure, high-speed connectivity that meets the demanding KPIs for bandwidth, for capacity, for latency will become a major value driver for telecom providers. The next phase of disruption with AI will blur the physical, digital, and human worlds. Physical AI systems need real-time interactions with the environment and instant inference results. Think of advanced robotic AI, autonomous vehicles, drones, and a new generation of intelligent consumer devices that enable immersive experiences. These systems will generate data at an unprecedented scale, characterized by a bidirectional data flow. Nokia Bell Labs predicts that the uplink requirements can grow 6 to 10 times faster than the downlink demand in AI-intensive environments. Physical AI systems need to sense and act instantly in the real world. That means networks must respond in just a few milliseconds. I think today we are talking milliseconds. Soon, it will need to be less than a millisecond. Front-running industries are making ambitious plans to scale their adoption of AI. It will transform their productivity and efficiency, and the telecom industry is in a key position to support this transformation. Now, this means that networks must evolve from delivery channels to integral components of the AI supercycle. In the US, 88% of enterprises were concerned that connectivity and infrastructure would limit AI scaling, while 78% of European respondents shared the same view. The equation is simple. Our industry needs significant investments in infrastructure so that connectivity does not become the bottleneck in this AI supercycle. More importantly, regulators and governments must create a favorable environment for capturing the benefits of AI. This includes simplifying policies and ensuring sufficient spectrum to support capacity expansion and the timely introduction of 6G. We also need to collaborate and co-innovate solutions that take us to the next level of connectivity. A great example is a collaboration with technology leaders like Nvidia, T-Mobile, SoftBank on the AI RAN and 6G. Telecom providers, together with AI and cloud companies, play a pivotal role in bringing AI to empower societies worldwide. The reality is that the regions that prepare most effectively will move fast and prepare well and will gain the most benefits. If access to AI is restricted, a new digital divide could emerge. We invite all our customers to be part of this development and lead the next wave of the AI supercycle.
Like Pallavi said, it takes co-innovation to stay ahead of the AI supercycle, and our collaboration with Nvidia is a groundbreaking example. Through this partnership, Nokia will be the first supplier to offer commercial-grade AI RAN products for 5G Advanced and 6G. Our cloud AI RAN solution is based on the Nvidia Arc Pro accelerated computing platform. And as the next step, our AirScale baseband will feature an AI RAN capacity plug-in unit. We are already testing our solution to run RAN and AI workloads on the shared computing platform with leading telecommunications providers. And there are many more collaboration steps planned. Let's hear it from Ronnie Vashishta, Senior Vice President of Telecom at Nvidia.
Nvidia and Nokia's partnership is not only unique, but it is also game-changing. The partnership will deliver AI RAN infrastructure that is 100% software-defined and ready for both 6G and the AI era. The convergence of AI and RAN brings many benefits to the telecom industry. First, AI will significantly enhance the performance and efficiency of RAN. Think of capabilities like dynamically learned air interface and ultra-precise beamforming. These are only possible with AI and directly translate to gains in spectral efficiency, energy efficiency, and network performance. Second, AI RAN will serve the growing AI inference traffic, making AI accessible to billions of mobile users and devices. By hosting or delivering these applications, telcos will be able to monetize the infrastructure by delivering tokens. With AI RAN, we are creating a fully software-defined architecture, which means new innovations can be introduced rapidly. The goal will be to introduce 6G features through software upgrades. A great example of Nvidia's collaboration with Nokia is our partnership with Indosat Ooredoo Hutchinson, a leading operator in Indonesia. Together, we are building an AI grid, connecting Nvidia-powered central AI factory to a distributed AI RAN infrastructure. The AI grid can host AI anywhere, from data centers to the edge, and can deliver AI applications over a wireless network using the AI infrastructure. This commercial-grade AI RAN deployment will be built on the recently announced Nvidia Aerial RAN computer platform, or Arc Pro, and Nokia's CUDA accelerated AnyRAN software. It's a blueprint that can be replicated by telecom operators worldwide to upgrade millions of base stations, making them AI and 6G ready. AI RAN is transitioning from proof of concepts to real-life pilots and deployments faster than many had predicted. Together with Nokia, we're accelerating the pace of innovation and building a strong foundation for the 6G and AI era.
Now we are creating a grid of 55,000 AI factories in every villages, and we want to give this message that we are taking AI to the people where they are. We got started in US with T-Mobile US. Then it was SoftBank and Japan. And we have been learning. We have been very blessed. Ronnie has been personally helping us. The next milestone will be application made in Indonesia in our sovereign AI factory supported by Nvidia and Nokia, which start benefiting people.
This collaboration is really a cornerstone for shaping the future of connectivity. It's also very inspiring that our industry can provide more inclusive access to AI innovation. Our long-term partner, Elisa, will now discuss the next steps in our co-innovation journey and how we will collaborate to make AI RAN a commercial reality. Over to Sami Komulainen Chief Operating Officer at Elisa.
The future of networks is AI-driven, and Elisa is leading this transformation together with technology leaders like Nokia and Nvidia. We've always been among the first to embrace innovation, the first in Europe to launch 5G standalone, and Nokia's first Cloud RAN customer in Europe. Now we are taking next step together, AI RAN. As traffic moves closer to the edge and services run on edge clouds, open, distributed and cloud-native architecture becomes critical. AI is reshaping traffic patterns, increasing uplink demand, and requiring ultra-low latency. For end users, this means faster connections, better quality, and enabling new experiences, like immersive AR and industrial automation. With this collaboration, Elisa is bringing AI RAN closer to commercial reality. The Cloud AI RAN solution runs workloads on common CPU-accelerated platforms, delivering simplicity, scalability, and cost efficiency. AI-optimized computing boosts network performance, improves efficiency, and reduces latency. This evolution is essential for advanced agentic and robotic AI, and for preparing the era of physical AI. Elisa has been a pioneer in network automation for over 15 years, and now we are moving forward fully autonomous network operations. AI-powered open architecture is key to achieving that vision. Together, we are taking a major steps towards software-defined radio networks and AI-native 6G. Elisa is paving the way in creating autonomous, AI-powered networks that will define the future.
This collaboration shows how partnerships drive real value. Now, let me welcome Wakikawa-san from SoftBank. They are one of the innovation leaders on the path to AI-native 6G.
I'm Ryuji Wakikawa from SoftBank. I'm leading the SoftBank research, mainly focusing on the AI RAN, 6G, and so on. As you know, SoftBank been promoting AI RAN, basically like a transform network, completely AI native, and also supporting the many of the AI applications, which is happening today. And AI RAN is a very important piece of it because it leveraging the AI technology to improve the radio, as well as serving the AI inference on the radio platform. We are very excited to have a collaboration with Nokia on this AI RAN journey. And we are very excited to see the big announcement Nokia made. We are happy that Nokia is evolving its solution to support the AI RAN demands, for example, by integrating GPU accelerating computing platform, which is very exciting. They are a critical component of the AI RAN architecture, make it possible to harness the performance and the efficiency benefit of the AI computing for radio. As you know, AI application require a lot of traffic bandwidth, and also low latency is necessary of some of the AI application, for example, like a physics AI. By using the AI RAN, we can deliver the best of the best network and optimize for the applications, maybe like ultra low latency network for some of the application, using all the 5G technology. We also expected the 6G technology coming out. So this is the best timing to see the lot of innovation happening in the mobile network. Let me also give you an example of a recent research at the SoftBank and transformer-based AI model for signal processing. In our trial, we have demonstrated that it brings a groundbreaking boost in spectrum efficiency and the throughput, while also delivering ultra-low latency. As we develop this AI RAN infrastructure, our goal is clear: to empower people and societies through the AI. And we are very excited to do a lot of collaboration and make it happen with Nokia. Thank you so much.
Exciting developments at SoftBank. As you can see, the future isn't waiting. It's our industry that is co-creating the future. AI is fundamentally transforming telecommunications networks, and it's also redefining the role of data centers. They're a critical component in capturing and multiplying the benefits of the AI supercycle. It's now my pleasure to hand over to David Hurt, who is leading this business segment at Nokia.
I am super excited about stitching together the elastic fabric of the network that brings together both mobile and fixed in this AI supercycle. We're living in some very exciting times. If you think about the number of data centers that are going up over the next 10 years, you're talking about 11,000 data centers with AI bandwidth that is continuing to expand. And we, again, that 24% rate on an annualized basis is very big. We haven't even hit edge inferencing and what that's going to do to both the mobile network and the network infrastructure that we're building here at Nokia. The data center traffic in between is growing at even a faster rate at 37%. And when you think about the number of devices and Metcalfe's law and what that's doing to the network effect of what we're doing, some exciting times ahead. As I mentioned, I'm super excited to build that elastic fabric for the AI supercycle. We are in the kind of catbird seat here at Network Infrastructure. We're number one or number two in every element of that elastic fabric that's interconnecting mobile, as well as the data centers powering this AI supercycle. So when you think about the edge of the network, we're number one in cell site routing and access aggregation. In the fixed line, optical line terminations that are driving fiber throughout the network, that is our business in the fixed network business, as well as in the IP business. We are, again, that catcher's mitt that's bringing all that traffic into the network. We're number one in fixed networks. We are number one in edge routing at that, again, edge routing portion of the network. And we're number one in optical, driving, again, that network traffic together. When that traffic comes together at the edge, you're seeing these data centers move up in terms of the architecture. Remember, I mentioned 11,000 of them growing. Our fixed networks products, our optical products and IP, and their number one or number two position are in the front end and the back end, both inside the data center, in both the front end and the back end, in the scale out architectures, as well as scaling across these AI factories. We are driving, again, huge price performance in terms of dollar per bit, cost per bit, agility and resiliency in that network fabric to be able to interconnect not only the network demands today, but when you start to change the dynamics of the upstream to downstream traffic with inferencing, moving from a 12-to-1 ratio to a 4-to-1 ratio, boy, the dynamics of needing that elastic fabric couldn't be more important. You're moving from 5 nines to 6 nines in terms of resiliency. You're looking for latency. Again, that's super important to the applications that are driving, again, in an inference world. We are, again, in great partnership with our friends in mobile infrastructure to make sure we're building that fabric as an elastic utility to make sure we're not only prepared for the network demands today, but again, tomorrow. What are we, aiming to do? Well, we're building out this massive scalable distributed compute architecture, both inside the data center and in the wide area network that is able to sustain, again, more bits per second while we drive watts per bit down in terms of the power that's driving the network. While we do that, we're being very open in our architectures. It's super important to who we are, to make sure that we're, again, driving an agile customer experience to drive new application development as we go. What are we made up of? Well, we're made up of that fixed networks, that IP networks that's driving the data switching and the routing in the networks, both inside the data center and outside the data center, as well as the optical connectivity that's driving that, whether you're talking about 10,000 kilometers below the sea, or whether you're talking about a couple hundred kilometers in between data centers, or, by the way, a couple of meters in between racks of GPUs inside the data center. One of the unique things we do here at Nokia is we're vertically integrated. We have our own fabs, building our own photonically integrated circuits, building our own chipsets for optical coherent DSPs, building our own chipsets for routing, as well as using open merchant silicon for switching, as well as, again, on the fixed networks, building our own silicon to allow 10 gig, 25 gig, 50 gig speeds without having to go out into the network to upgrade, being able to do that via keystrokes. So We're excited to be here. We're excited to work with the Mobile Infrastructure Group to power this AI supercycle, and to do it together. We're investing our dollars and increasing our R&D across all three of the fronts of IP, optical, and fixed networks to, again, build that elastic utility for you.
My heartfelt thanks to all our speakers and those who joined us today. But wait, what do you think? Did I do better than the real me last year? You can let me know which one you prefer when you visit our booth at Mobile World Congress in 2026. Bye for now.